Hey everybody, I hope you're doing all right and that you're healthy and sticking together as a family and making good choices together. Uh, I know it's sort of a weird time to do videos, but we're doing the best we can to get through it. Now I know you don't have dad jokes from Mr. Zink, so I'm putting my 4-year-old daughter in charge of joke time. So we're going to start with that. So hang on just 1 second and we're going to get a joke.
Why was the cheetah so bad at hide and seek? No matter where he hid, he was always spotted. Get it? Yeah, spotted.
Awesome job. All right, Mr. Zink, eat your heart out. All right, let's get started. So as promised, we are going to work on the odd problems of the chapter review together. And then you are going to work on the evens on your own, and the even ones will be the ones that I check. And then we'll do like we've been doing, where every 24 or 48 hours I'll give you an update on what you got wrong, why you got it wrong, and we'll go from there. Hopefully we'll get all caught up in all that grading. Hopefully the comments have been helping. Obviously they do take time, but I'm trying to do things a little bit differently so that we can all work together. Anyway, so let's start with number 1 if we're going to do the odds here. And the first thing to remember is that if you are dealing with a tangent line, it makes a right angle to a radius or a diameter. So that's why we always have triangles in these pictures. It's because if you have a right angle right there and triangles add up to 180, that means you could just subtract the two other angles to figure out what's left. So if you start with 180 degrees, and then you take away 90, and then you take away 58, that tells you what x is going to be. And in this case, x is 32 degrees. All right. We bounce along here. We're going to do problem number 3. And if you look at angle x right here, it is a central angle. Now what we know, central angles are the same as the arc. Whatever the arc is, that's what the central angle is. And just like arcs always add up to 360, central angles also add up to 360. So what that means is if we were to break this thing up, and it is a regular pentagon, by the way, it's got 5 sides. If you were to break this whole thing up into 360 degrees and then divide it by 5, you would end up getting what you're looking for. So in this case, that's what I'm going to do. I'm going to take my 360 degrees, I'm going to divide it by 5, and I'm going to figure out that the missing angle is 72 degrees. Okay. Now I know we're kind of bouncing back and forth, and we've got some different ideas for how to do these problems, and it's kind of hard to get in a rhythm when you're only doing the odd ones, but we'll be okay. Okay, so we're going to jump over to number 5, and it's going to be completely different, and that's just fine. So you look at problem number 5. Find the value of x. Now the key to this problem, other than the fact that it's a right angle, is that the radius is 3. That means no matter where you put the radius, here or here or here or here or here, it's going to be 3. That's actually the key to getting this problem right, is because you need to put a 3 right there as well. Once you get there, it's going to be a right triangle, which means we're going to do the Pythagorean Theorem. 3 squared plus x squared equals the hypotenuse squared, which has a 3 and a 7, which means the whole thing is 10. All right, so you get 9 plus x squared equals 100, and you end up getting kind of a weird one because x squared equals 90. Now this is going to be one of those, you're going to have to get your calculator out. I tried opening mine on the computer, but this is a different computer, and it was a different calculator, and it did not look very user-friendly, so I am just going to go with this. Rounding to 2 decimal places is perfectly fine. If you're into simplifying radicals, that's great too, but in this case, 91 does not simplify anyway, so it's not going to do you a ton of good. So why don't we just go from there? So x equals 9.54. All right, now, we've done a lot of problems like number 7. We did one on a quiz. We've done it all over the place where we try to find the perimeter. And it's based on the idea that if you have a tangent segment and another tangent segment, and they come from the same point, then they are congruent. So, for example, in the picture that I just sketched out right here, you're going to find out that this and this are congruent. Now, the value of that is that now we can go through and we can do perimeter. And when we do perimeter, we can go piece by piece and take the information that we know and build on it. So, for instance, if we know that this piece right here, this red piece, is 6, that means the red piece to the left of it is also going to be 6. Once we get there, we can just start subtracting from the whole thing. So, for instance, if we know that that whole length is 9 and we've used 6 of it, that leaves us with 3 left. And then we could do another 3 going the other way right here. And then last but not least, if you know the entire length down below is 8 and you've used 3 of it, that means you have 5 left. So that means we're going to go 5 and 5. So the perimeter of the entire thing is a couple of 6s, a couple of 3s, and a couple of 5s. So you end up getting 10 plus 6 plus 12, which would be a total of 28 inches. Okay, number 8 is going to work exactly the same way, but it's going to be a little bit more complicated because we are dealing with a pentagon. All right, now we go on to number 9. Find the length of the radius of each circle. Now, I don't know if you noticed this, but they didn't actually draw the radius of the circle in this case, so we're going to have to draw our own. Now, we could draw it right there. 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 It doesn't really matter where we draw it. The most valuable place to draw it, there are actually 2 ways to do it, but I'm going to put mine right there. And since I don't know the length, I'm going to call it X. Now, if I focus only on trying to figure out the radius, that means I'm going to focus only on making a right triangle out of it, which means I don't actually want to use all 24 feet of that chord. I'm just going to break it off and use 12, which means I'm going to say 5 squared plus 12 squared equals whatever the radius is going to be squared, because the radius is the hypotenuse. So you end up getting 25 plus 144 equals x squared, which will come out to 169. And then you take the square root of that, and hopefully you know by now, because this one has come up a lot, the answer is 13 feet. Now, it's not always going to come out that pleasantly, but in this case it came out just fine. For an example of one that doesn't come out as nicely, let's try number 11. I don't see the marking for number 11 here, but that'll just have to do for now. So I'm going to draw in a new radius, and I'm going to call it X. And then, again, if we want to solve for the radius, we're going to have to base things on the right triangle, so I don't want the entire 5. I only want half of it, which is going to be 2.5. So I'm going to go with 2 squared plus 2.5 squared equals x squared. And like I said, they don't always come out very nice. So sometimes you're going to have to do a square root and just deal with it. And if we do that, we're going to take the square root of 10.25. You'll have to get out a calculator and deal with that, just like I'm doing over here. And you're going to find out that the radius of this thing is going to be 3.20 centimeters. Alright, now that is going to make sense because it is the hypotenuse, so it needs to be the longest side. Okay, that got out of control. I'm not used to this mouse, but we'll see what we can do. Alright. Now, sometimes they are going to make you solve for one of the other pieces, not just the radius. So in this case, we're going to have to take the radius they gave us, which was 7, and we're going to have to swing it around so that we can use it to our advantage. So in this case, we're going to swing it around and put it right there instead. And then that means we're going to have to solve for one of the other sides of the right triangle. So again, we're not going to use that entire x length right now. We're just going to use that green length. And remember, since it's not the hypotenuse, we can't call it c. We're going to have to call it a or b. So I'm going to do this. 4 squared plus b squared equals 7 squared. All right, so that's going to put me right here. And from here, I feel like most people are pretty good at it. Although there is one extra step that a lot of people have been forgetting that we need to take care of. So you take the square root of both sides. And if you take the square root of 33, you're going to get 5.744. So B equals 5.744. Now this time it said round to the nearest tenth, but don't do anything yet because that's not actually the answer. If you want to know the answer, remember x was marked from the entire left side to the entire right side, so you're going to have to actually take that number and multiply it by 2. Try to do that while it is still in your calculator. That way you never have to worry about rounding issues or anything like that. And then at the end it said round to the nearest tenth, so we should probably do it from there, and we'll call it 11.5. Now, when it comes to perimeter, things that involve an actual unit, we try to be careful about labeling it. If you call this 11.5 units, that's great. If you just call it 11.5, that's fine with me. I will be more picky about it if we're doing a problem that actually involves area or perimeter. In this case, I would accept either answer. All right, number 15. Now this one is super fast, and I'm going to zoom in on this one because I think the picture is going to be easier to see and work with if I zoom in. The answer is super fast if you know what you're looking for. If you don't know what you're looking for, it's going to take a really long time. So let's talk about our shortcuts. We learned that in a central angle, the angle is whatever the arc is. So if the arc is 60 degrees, that means that angle is 60 degrees. Which means what we have here is a 30, 60, 90 triangle. Now, I don't know if you remember the rules for our 30, 60, 90 triangles. So just a quick refresher. A 30, 60, 90 triangle is half of an equilateral triangle. So whatever number this is, let's say this was 5, this will always be twice as big, and then the height would be 5 radical 3. That was the shortcut. Okay, now I bring that up because if we have created a 30, 60, 90 triangle, we might as well use the shortcut. X is going to be twice as big as the smaller side because it is the hypotenuse. So if you remember the trick, then you know that x equals 4, and we are done with that problem. Obviously, if you didn't remember the trick, it was going to take you a lot longer. So that's why we learn it. We don't learn it because I'm trying to be annoying. We learn it because I would rather you save yourself some time. Okay, so we did that trick a lot, and we will continue to do it a lot. In this case, it saved us a lot of time. All right, number 17 would be the other trick. Now, I don't know if you remember this, but this was the 45, 45, 90 trick. Basically, if I know that two sides are going to be the same, then that means I also know that two angles are going to be the same. And in the case of a right triangle, both of those angles have to be 45 because there's only 90 degrees left. Now, the trick behind this one was that if you have, let's say, 8, for example, you have an 8 here and you have an 8 here, then this one ends up being 8 times the square root of 2. My computer got a little bit laggy there, so I apologize for that, but 8 times the square root of 2. Now, the reason I bring up that shortcut right here is because the radius of a circle is whatever it's going to be no matter where you put it, which means both of those triangle sides are 15, which means we can use our shortcut and we can say that x equals 15 and then throw in the square root of 2. Okay, so by using the shortcut, we save ourselves some time. If you felt like using the decimal version, that's all right with me, and you would get 21.2. but I just want you to understand where it came from, just so you can save yourself time in the future. All right, time to zoom out here. Now we're going to get into some of our angle work, which should be helpful. We'll jump into problem number 19. That is our first appearance so far today of an inscribed angle. And whenever you have an inscribed angle, it's not going to be the same as the arc. It's going to be half the arc, which means what I actually want to do first is solve for y, because that seems to be seems to go with what we just talked about. If the angle is 35 and the angle is half the arc, that means the arc has to be double that, which would give you 70. Now, I suppose it actually would have been easier to look at x, because whenever you have a radius or a diameter and a tangent line, it makes a right angle. So it turns out x equals 90. So we could have done it in either order, because neither of them were very scary. All right. Let's go to 21. 21 is where we do our average rule. Now, the average rule says that if you want to know the measure of an angle that's inside the circle, so again, it's not a central angle right in the middle. It's not an inscribed angle, one that's actually on the circle itself. It's actually somewhere in the middle. What you have to do is take the average of the two arcs that are intercepted. Now, when I say intercepted arc, what I mean is if you took this angle and you extended it farther in both directions, there is an angle there. That angle cuts off this arc. That is the intercepted arc. All right. Now, the reason we have to average the two arcs that are intercepted is because right here, what we have on this side is a vertical angle to the other one. So when you look at this other angle on the inside right here, it's going to be the same as x was, because it's a vertical angle to x. So that means we can't just ignore this arc. We have to consider both arcs, which means we're going to average them and see what we get. So we end up getting 128 plus 34, which would give me 162. Now remember, when you're averaging two numbers, you have to add them, but then you're going to divide by 2. So you're going to do 162 divided by 2, which means x equals 81 degrees. All right, let's go to 23. Let's see what rule we can use here. Well, let's take a look. The angle that we're working with is on the circle itself, which means it is inscribed. And we know that an angle is half the arc, which means that arc that it cut off is actually 268 degrees. That is a lot of degrees. Now, since a circle has 360 degrees total, all we really have to do is 360 minus 268, and we'll get what we're looking for. And it turns out that that measure of angle x is 92. Now, in this case, I'm not going to include the angle symbol because they already included one. For 21, they didn't. That's why I did. All right. We're closing to the finish here. We only have a few more to go. So remember, you can pause, catch up, do whatever you need to do as you go. Let's get on with 25. Now, 25 is the world-famous ow-ow rule that I referenced in circles lesson number 4. It's where you do the outside of one segment multiplied by the whole thing, and it's going to equal the outside times the whole thing of the other. It's the ow-ow rule. So, when we use that rule, let's start on top, and let's mark the segment green. The outside part is x, and the whole thing is 6. All right, now you go to the second one. The outside part is 3, and the whole thing is 7. So what you end up getting here is 6x equals 21, which means x equals 3.5. Okay. All right. Let's try one more ow rule, and we're going to do this rule. It's going to be a little bit different. We're going to have to do a little bit of work here. We're going to have to distribute something, and you'll see why in just a second. Usually when they get really bad, you begin to understand why I call it the ow rule, but we'll just move on from there. All right, so the top line I'm going to make, we'll just make it blue. And so we will say that the outside of the blue line is 11. The entire thing, we didn't get any convenient markings like on 25, so we're going to have to add up the pieces and get 21. Now, if you look at the other line, the outside is 12, and this is where kids get it messed up, so be careful. The whole thing is the 12 and the x. You have to add them, and you get x plus 12. So that's the one that people mess up all the time. So I just want to make you aware of it because it is going to come up again and again and again. It always seems to. So on the left side, you do 11 times 21, which is 231. On the right side, you distribute, and you get 12x plus 144. Last but not least, you need to subtract from both sides. So hopefully you subtracted 144 from both sides. And when you do, we should be really close to what we need, because now we just have 87 equals 12x, which means x is going to equal, oh, that sounds like 7 1/4, but I really think I should probably check my work here because I don't want to be wrong on a recording. All right, looks good. X is 7.25. All right, we're doing good. We're not far away. Now, I just want to throw something out here really, really quick. I don't want to do number 28 with you because I only want to do the odd-numbered ones, and I want you to have to do the even-numbered ones. But I do want to remind you of the rule, just in case you forgot it. When it comes to a problem like this, all you have to do, let's say this is 4, and this is 6, and this, let's say this is 3, and I'm just making this up off the top of my head. I feel like this was on an earlier paper. Whenever all of the pieces that you're working with are inside the circle, all you have to do is multiply them bit by bit. So you could say 3 times x equals 6 times 4. And then in that case, you would just have 3x equals 24. And if 3x equals 24, x would equal 8. Now, I know that problem wasn't on your paper, but I want to make sure you understand that that's how the rule works. Now, when you get to a problem like 28, make sure you know that if you're doing 5x times x, it's actually going to be 5x squared equals 180. Again, I don't want to do the whole problem for you, but that's what the setup is going to look like. Then you're going to have to divide and eventually take a square root. All right, you've made it a long way. We only have 2 more to go here, and I'm going to have to zoom in for number 29. Because there's a lot going on. We're going to need to solve for x. We're going to need to solve for y. We've got a lot to do here. Now, when I'm looking at a game plan for what to do, I can actually do x and y separately, and there's no rule about which one I'm going to have to do first. We do have some pieces that are on the outside, however, so we're going to have to do the ow rule. Now, if we solve for y first, I want to bring this up because we haven't done one like it yet. If you want to solve for y, in that segment, the outside is the whole. So since that segment never actually goes inside the circle, the outside is y and the whole thing is y. So you actually just do y times y, which would be y squared. Then you look on the other piece. The outside part is 7. The inside part would be 15 plus 7, which would be 22. And you end up getting y squared equals 154. Now that one doesn't come out pretty. It didn't tell us what to round to in this section, if I remember right. So in this case, I'm just going to take the square root of 154 and go to 2 decimal places. Also, if you accidentally don't round to what I want you to round to, Just keep in mind, you know, this is not really the battle I'm going to fight right now. We just want to keep practicing and doing the best we can. Okay, so that's how we are going to solve for y. Now, when we're doing x, I don't really want to deal with that 12.41 part anymore, although either way it's going to set up the same way. So what I'm going to do here for this problem, I am going to try to work on the green line, and then I'm going to compare it to the blue line. Okay, so for this, what I'm going to get, if I do the ow rule, is 5 for the outside, then the entire thing is x plus 5, and then that's going to equal, once again, if we use that blue line, 7 times 22. So that's going to give me 5x plus 25 equals 154. And if I subtract, I get 5x equals 129. And then x, if you divide 129 by 5, it sounds to me like you're going to get 25.8. Double check me here, because that would be pretty bad if that wasn't right. So y equals 12.41. X equals 25.8. All right. All right, last problem of the day is going to be problem number 31. Now, my first instinct on this problem was completely wrong. What I wanted to do was just focus on what was inside the circle and completely ignore what was on the outside of the circle. But if you do that, you're going to have an x and a y at the same time, and you're not going to have enough information to get the answer right. So what you're going to have to do instead is do the ow rule first, use it to solve for x, and then take that number to get your y. All right, so that's what we're going to do. If we do an ow rule, that's going to leave you with, if you look on bottom, the outside and the whole are the same thing because that segment of 11 never actually makes it inside the circle. So I'm just going to say 11 times 11 equals, and then on that top line, the outside is 7, and the whole thing is actually 5 plus x plus 7, which would be x plus 12. So you have to add up each piece. Okay? Then when you distribute, you're going to get 121 equals 7x plus 84. Subtract 84 from both sides, and you get 37 equals 7x. This one we're going to have to round off because it's not going to come out very pleasantly. If I remember right, it's 5.29, but I'll double check that as well because I don't want to mess that one up. Yep, sounds good. All right, so we'll just leave that there, and then we will use that information to solve for y. So now that it's time to solve for y, what I want you to do is just pretend that none of this outside even exists, because then all we have to do is just use our regular rule, which says anytime both segments are inside the circle, you just have to multiply each piece. So you get 5x equals 9y. Which doesn't seem like you're going to get anywhere with it, but we know that x was 5.29, which means it'll be really easy to wrap it up. So you take that number, and you still probably have it in your calculator. If you multiply it by 5, you're going to get 26.43. And if you're wondering why I got something slightly different than you, I left the previous answer in my calculator and didn't round it. If you got 26.45, really, it's not going to matter. It's going to change your answer by a couple of hundredths. It's not that big of a deal. Anyway, so now you're going to take that number, you're going to divide by 9 because we have to solve for y. And I got y equals 2.94. If you... well, no matter how you did the problem, you should end up getting that same answer. If you don't, then it's going to need to be fixed. So, Anyway. All right. Well, I know that was about twice as long as I usually go, but there was a lot of review that needed done, and I hope I helped you out. Take care of each other. Stay safe, stay healthy, do the best you can. If there's anything you need, email me, reach out on Google Classroom. Even over spring break, I'll be checking pretty much every day just to check in if I need to. So, take care of each other, be good, and I'll see you next time.